Dear students, in this video we are going to see the experiment number 4, single layer perceptron for the course 20CS 2032 Machine Learning Techniques Lab. To work with this algorithm, first we need to know the basic terminologies available in the single layer perceptron algorithm. So perceptron is similar to a single neuron available in the biological neural network. Perceptron are the basic building block for the artificial neural network. The extension of the artificial neural network is the deep learning techniques. The word perceptron is first coined in the year 1943. Later, Frank Rosenblatt, a computer scientist, built the first perceptron machine learning model in order to perform an image recognition task. Perceptron algorithm is based on the concept of the working principle of the single neuron available in the human brain. A single neuron will receive the signal from the other neuron and it will process the signals through its nucleus and later it will be transmitted to the next neuron. This is the structure of a single neuron available in the human brain. Here, the neuron will receive the signals from the dendrites and it will be processed in the nucleus. Later, the output will be transmitted through the axon. And this is the structure of the perceptron, or it is a node in the neural network. And here each node will receive the signals as an input. If the input is high, it gets activated in the neuron, and based on that the output will be generated and transmitted to the next neuron. And X1, X2 represents the inputs and W1, W2, W3 represents the corresponding weight connections between the input neurons and the output neurons. The weight represents the strength between the input and the output neurons. And here the nucleus represents two actions. First one is the summation and the next one is the activation. So during the summation, the input and the weights are multiplied and we get the weighted sum. So we can get Z is equal to sigma X and W. So now this weighted sum will be given to the activation function. Based on the weighted sum of the input signals, activation function produce the corresponding output which will be transmitted to the next neuron. Perceptron algorithm is a type of linear classifier which is mainly used to solve the binary classification problem, where the data will be classified in a linearly separable manner. So we get a separate class as class 0 and class 1. And here the activation function makes our data to label either class 0 or class 1 as an output. And how it will be differ from the logistic regression binary classifier. In logistic regression, the activation function will be considered as sigmoid function 1 by 1 plus e power minus x. So the output what you get is a probability. So based on the probability of the data, whether it belongs to class A or class B, we will divide the data into class 0 or class 1. And this is one of the example how the data will be classified to a binary class of 0 or 1. And these are the inputs. So we have three inputs for the node X1, X2, X3. And these are the corresponding weights assigned to the input W1, W2 and W3. And the node having two functions. First is the summation and next one is the activation. So during the summation, we will get the answer is sigma X into W. So multiply each input with the corresponding weight, we get the weighted sum. And during the activation, we have passed this input to the activation function. So the activation function have some threshold values. Based on that, the output, we get the label of the class, either it belong to class 0 or it belong to class 1. In the summation function, we can add bias. What is the need of the bias? If one of the input of the perceptron is 0, so this will not give a good estimation during the training process because when we multiply 0 with weight, there is no effect of the summation. So we are adding a new term to the equation which is called as the bias. The bias will shift the decision boundary either left or right during the training process based on the input data so that we get a linearly separable boundaries. The new term we obtain is the summation of XW, that is the input and the weighted sum plus the bias added to the network. So we have inputs, we have the weight, along with we have added the bias. The bias can be a single value. It can be a minimum of 0, or we can give a value that is a small values you can give for the bias in order to make our decision boundary to be shifted to make a linearly separable output. Activation functions. So once the weighted sum has been calculated, the perceptron has to decide when to be activated. The weighted sums are collected and it will be passed to the activation function. So that will produce the output of the class label 0 or 1. There are various activation functions to the perceptron, that is sign function, heaviside or step function, sigmoid function, ReLU function, etc. And generally in the perceptron learning algorithm, we will use the heaviside function or sigmoid function. And here we are going to consider the heaviside or the step function. So this heaviside or the step function using a threshold that, so if the value computed from the weighted sum is less than 0 means the output will be going to the label 0. If the weighted sum value is greater than or equal to 0, the data will be grouped under the category of the class label 1. So this is the way how the step function will divide our data based on the weighted sum either to class 0 or class 1. And the Hebb's rule will be followed in the perceptron learning algorithm because once the weighted sum is calculated and the activation function produce the output is either 0 or 1, we need to calculate the error. So based on the error, the previous weight has to be updated so that we will get the good accuracy model. So the algorithm will be trained in every step in order to update the weight until we get the optimal output. And this is the training rule. The new weight is calculated based on the old weight and the learning rate followed by the error which is calculated between the actual output and the predicted output, and that will be multiplied with the current input. So here the inputs are passed. We calculated the weighted sum and the activation function produced some output. So that is the predicted value. Now we need to calculate the error between actual and the predicted. Based on this error and the learning rate, the new weight get updated by changing the old weight. And this is the steps of the algorithm we need to follow in order to do the binary classification for the given input. This is the input given and these are our input nodes. That is X1, X2, X3, X4, X5 and X6. So here these will be considered as an input for our node. So we have X1, X2, X3, X4, X5 and X6. And this will be having the corresponding weight. So these weights will be initialized randomly or it can be initialized to 0 in the beginning. And based on that, the summation will be calculated and we are using the heaviside function so that activation function get activated and we will get the output for the label of the class. So first we need to identify how many number of inputs we need for the particular node and what is the output class. So since here it is only a binary classifier 0 and 1. So we need to go through our data set and we need to identify is there any null values available in the data set before doing the classification process. And if there is any null value, that values get imputed by the mean concept. And the next is the label encoding. So our output target is the categorical data. So the categorical data need to be converted into a numerical data by the process of label encoding. So all type 1 will be renamed to or labeled to 0, normal will be labeled to 1. And next we need to divide the data into a training set and the testing set. And we need to initialize the network parameters in order to start the training process. So we need to initialize how many number of iterations you need and what is the learning rate we need to initialize, and initialize the weight and the bias. So whenever you train the algorithm, you can stop the algorithm in 3 categories. That is, when the epochs reached, that is the number of iteration reached, or the error having some threshold. So if you reach a minimum error, you can stop it. Or if you reach a required accuracy, then also you can stop the training process. So first we need to start the training process, and here we are setting the number of iteration, and for every iteration each input will be taken. Instance means one input. So that input will be taken and we have to compute the weighted sum average for that particular input, and that will be, here we have the summation x into w plus bias, and this value will be given to the activation function, and based on the activation function we will get the y predicted value, and we need to calculate the error y minus y predicted, and based on the error, learning rate and the old weight, the new weight get updated. And once the iterations finished, we need to finally display the final weight after the training process. And we need to plot the curve between every iteration and how the error rate get decrease. And once it is done, we need to go to the testing process. So by using the testing data, we need to test our model. The performance of our model get evaluated based on accuracy, F-score, recall, and precision. So now we will see the corresponding Python code to do that particular single layer perceptron algorithm. So first we initialize the training data, epochs. Before that, after reading your data, we need to divide your data into training and testing. So split your data into training data and the testing data. We initialize the number of epochs. We initialize the learning rate. And we are invoking a function in the Python called model. We are passing the training data's input, training data label, learning rate, and the epochs. So this function helps you to find the final weight of the particular model. And here to take the inputs, because the X contain the shape represents the number of rows and the columns. So we need to take the number of features available. So that will be available here. And once it is done, we have to initialize the weight. So the initialization can be either done with 0 or you can assume with random weights. The bias here considered as 1. So now we start with the epochs using the for loop. In every iteration, we take each instance. For every instance, we need to calculate the sigma w x plus bias. So this is our output of the summation. And now that will be passed to the activation function. And the heaviside activation function will produce the label either 0 or 1. So based on the value, if the sigma value or if the z calculated value is less than 0, the predicted value will be 0. If the z value is greater than or equal to 0, then the predicted value will be 1. So based on the prediction, we are calculating the error. So the error and the learning rate and the old weight, we are updating the new weight. So old weight plus learning rate into error into the X input. The bias also we are trying to update based on the learning rate and the error. So every time the error value get recorded in this array. That will be used to plot the value for every iteration, how the error gets reduced converge the algorithm, you want to know it, the plotting. So we are storing that errors in the list error array. So at the end of the iteration, the weight, bias and the error value in every iteration get returned back to the original program. And this is the activation function. We are using the Heaviside function. The Heaviside function will perform if the value is less than 0, it will return the label is 0. If the value is greater than or equal to 0, it will return the label is 1. And once the training process is over, now we need to move to the prediction. During the prediction, we are passing the test data. So we will get the predicted value for the test data. So we have to find the accuracy of the model. So there are various performance metrics available in the scikit-learn library. So we have to import that library and we can calculate the accuracy score, F1 score, precision score, recall score and the whole classification report and the confusion matrix. So the confusion matrix is nothing but we are having two class labels. So either I have a class 0 and class 1. And here also I have class 0 and class 1. So this is actual and this is predicted. So out of how much actual values class 0 is predicted correctly class 0. So that count we will write it here. And how many class 0 is falsely predicted as class 1. So that will be written here. Actually it is class 1, but how much it is predicted as class 0. So that will be written here. And actually it is class 1, predicted also class 1. So this two only provide your accuracy. So C1 plus C4 divide by the total value. That is C1 plus C2 plus C3 plus C4. So that will be giving the accuracy. So this should be maximum. The class 0 is maximally predicted as class 0. Class 1 maximally predicted as class 1 so that your accuracy get improved. So we can adjust the learning rate, we can adjust the number of iteration so that we can achieve the good accuracy for the model. So I hope you all get a clear idea how the single layer perceptron algorithm is working in order to solve a binary classification problem. Thank you.